Resume recording. I found it. It's Alt-P, abrupt transition, but I think that's an important message to share. Okay, so what I'm going to do first is I'm going to talk a little bit about who we are and how we got here and what we can do with R. And I often like to say that this is a eat your own dog food kind of presentation. And what I mean by that is I've used R to do everything that you're going to see today: the slides, the visualizations, the coding, putting it up on GitHub. All of that has been orchestrated through R. It's often been said that R can be a universal or ultimate interface to kind of workflows that are reproducible. And I hope to model those for you. And so you can see some of the things that can happen with R. The one exception is, of course, many of you have filled out introductory survey forms, and the survey forms are part of Google, and the registration system is a third-party company called SpringShare. But otherwise, I'm taking in the data and using R to manipulate it. In the case of the Google Forms, you can even use R to pull the data directly from Google. So here's what I wanted to show you on this slide. We are this kind of makeup that I typically see. I think this slide might be a day or two out of date, but it's generally right. We generally see engineering, bio, stats, that kind of stuff in the top group, and usually we are very much a grad student heavy group, although my center is available to anybody on campus, and we often see folks from all walks of life on campus, and we're happy to have you. Here's another visualization. The point that I want to make with this visualization, actually wouldn't necessarily recommend it. I don't think it's a great visualization, but it's the exact same data using really just one or two different commands or functions out of Ggplot. And it presents it a different way, and so it's just breaking it down by graduate student, by staff, by faculty. And you can see much the same kind of information. I did a time series, just pulling in, marking off how many people filled out the survey and at what point. This is not in real time series. I can't do that, but this is, I think, up to date to about 10 a.m. this morning. A really interesting comment that I'm trying to understand myself is that for some reason, this introductory group tends to be a really high responder in terms of a response rate, but in my part 2, I generally don't get nearly as much of a response rate. So I find that really interesting. But I admit I don't have the time to design a full-on, sociological study of what might be happening there. But this is what we're going to try and cover some of this stuff today. And I always like to ask this question, like, where are you and how do you fit into this group? It helps me understand what I can kind of move a little bit faster with or a little slower with. Not surprisingly, I would say more than half of you, close to 2/3, are coding less than once per year. So you're definitely in the right place. But there are people who are coding daily. It's possible that the people on either end of this bar, the folks who are doing it daily and the folks who have done it never, will feel either frustrated by the slow pace or frustrated by too quick of a pace. That's okay. What I like to remind people is that I am available for consultations. It's great if you can watch the videos or you can stay through this session. But if you're feeling really behind and lost, I'm sympathetic to that. I don't mean for that to happen, and I will happily meet with you later. We'll talk some strategies on how to do that. And if this is really too slow for you, again, some of the most useful ways to really leverage your R knowledge is to work on your very specific project, but we won't have time to work on your individual specific project today. We'll do that in a consultation at your convenience. I'll send some information out about that. I generally like to ask people how much they've used models, some kind of statistical modeling. It's a similar kind of graph, but there's a really large group who's using models several times a year. So R is a natural language for that kind of thing. The two languages that we support most frequently in my center are R and Python. And quite honestly, you could use either one for this kind of thing, although what I would say distinguishes R. R is generally referred to as a data-first programming language, meaning it's all about the analysis, whereas Python is effectively more of a general programming language. So if you're kind of really into coding, you're wanting to make apps, that kind of thing, maybe Python is better, but they're both Turing compliant applications. They both do a whole bunch. There's only one thing I'm aware of that Python does that R doesn't, which has something to do with controlling microcontrollers, which honestly, I don't even really know what that means. I know it's something I'm never going to do. I'm much more into the data. Um, the other nice distinguishing feature about R, I think, is that it has a very modern and rich and complete sense of the full data lifecycle, which means you can do so much of your work in R. And the more work you can do in R, the more likely you can generate your work as reproducible outputs, which is a goal for many. I often ask about version control because version control is which would be, I would define as using Git and GitHub, although there are other aspects, is a foundational importance to reproducibility. It's fine that you haven't used these so much. I do have a workshop on version control, and I'm happy to point you to that. I often ask about shell or command line interfaces, similar stuff. Not a lot of expertise in this, but an important comment to make is that in a lot of ways, Python and R as programming languages are effectively command line interfaces. In other words, they're not point and click so much. And one of the values of that, as the world evolves into a more sophisticated understanding of like computational thinking and computational workflow, is that point and click interfaces are often not very reproducible, whereas command line interfaces can be strung together in a linear way. And so those two things kind of go hand in hand, version control and shell. And then I'll usually ask about databases. Not a lot of people using databases, but I like to make the comment, especially for those of you who are using databases regularly, that R has a very nice package called Dbplyr, and Dbplyr enables you to interface, Dbplyr and a couple other packages enable you to interface directly, querying databases directly. And one of the nice things about Dbplyr, we're going to talk about Tidyverse and Dplyr, is that once you learn the Dplyr verbs, you can actually use those same verbs to query the databases, and you don't actually have to learn SQL, which may be a good thing. I think it probably is if you don't want to be a database engineer, but you just want to deal with the data coming out of a database. Works great if you have a database administrator managing the database, and you can just deal with the data. Okay, so this is really the main reason why I asked the survey. I like to get an idea of where people are in their R journey. Surprising to me this time, but it's great, is that about at least half the folks said, yeah, I'm good with importing data. So that's really great. It's a little more mixed on the editing scripts. A huge part of today's discussion will be about subsetting data, and it seems that that's going to hit the right note. We're going to talk about projects and reproducibility and importing data, in that they all kind of lend themselves, in editing scripts, they all kind of lend themselves to best practices. What can you do to make your scripts reproducible and easily used not only by others, but quite honestly, the target of reproducibility is actually yourself. Because within 6 months, you're going to forget all the things you wrote down. And it's just helpful to have these good practices. Okay. I like to ask about data management workflow. Reproducibility is one aspect of that, but I also like to ask because R will help you with your data management, but also because in my center, we have 2 data management experts who will help you. Data management is becoming more and more important in the academy. A lot of times we can help you with the data management tools, so you're getting, you're more likely to get the grants written in a way, the grant applications written in a way that promotes data management. And we can also help you at the end of that project process with ingesting your data outputs into the proper repositories, including the repositories that the general repositories that the university manages. This next slide is really just another one of those, check out how cool R is. This is the exact same code with one switch, just using a Ggplot theme. And it's just nice that I didn't have to think about all the colors. I just used one other theme. So I'm just trying to show off some of the things R can do. Now, RStudio, Tidyverse, they're all related. R is the programming language. RStudio is an application that sits on top of R that makes it easier to program in R. And the Tidyverse is a collection of packages that work well together that kind of brings R, a statistical language, into more of a data science, data first context. One of the things that the RStudio Tidyverse community is well known for is being helpful. You can Google this anytime you want. You can Google the phrase RStudio community. You'll find a online board full of people who know a lot more about R than I, who will help you when you're like, I just don't know how to iterate through my data frame, or I don't know how to do this, or I don't know how to do that. But to bring that a little more locally, last semester I started a Microsoft team called Rfun, because Rfun is my sort of branded series of workshops on R. And I put it into the university's Slack-like tool. It's called Microsoft Teams. Many of you will know what Microsoft Teams is. You can get to Microsoft Teams through Outlook. And if you're in Teams, you can click on this little Teams button. If you're in Outlook on the web, you can click on that little Teams button, and you can click the Join and Create button. And then there is the code. You can take a picture of this if you like. Or you should be able to click on that link and join that way. As far as I know, this is the way I tried to set it up. This is specific only to Duke. You have to have a net ID in order to get into this team. I started this last semester. It got a little bit of traffic. My goal is to recreate a local helpful community where people can ask questions and answer questions, ask and get answered questions, or maybe you know the answer. Everybody knows something about R. I don't mean to be the university's only expert on this. Indeed, I am not. But it is my job to be helpful. So this is my approach at trying to cultivate that community. So feel free to join the Microsoft Teams Rfun Teams site and post your questions there. Because, of course, some of you might be working at midnight, and I assure you I am asleep, or ideally asleep by midnight. So I'm not going to answer your questions at midnight, but you might not want to wait. Feel free to take a picture of this. I think I've sent you a lot of these links already, but you can schedule me for consultations. All of my colleagues are available for consultations, so you can email us at AskData. I've got Drew on the line. Drew is a GIS specialist, helps with mapping. Drew's colleague, our mutual colleague, Mark Thomas, is a mapping expert. Our colleague, Eric Monson, specializes in visualization and knows a lot about Python and Tableau and knows some MATLAB. I mentioned our two specialists in data management, that's Sophia and Jen. And then we also have two econ grad students who are in computational economics, who happen to know a great deal about statistical models, much more than me. The econ students only interface with people through a chat interface. All the rest of us will make appointments, but they only get paid for X number of hours a week. So you can go to our site and you can connect with any of us. I encourage you to try and connect initially through the email, but the chat service is available all the time. The reason why I say the email address is, I mean, you're welcome to send me email directly. I'm happy to get it, but you don't know if I'm on vacation or whatnot. Whereas the Ask Data email will be more of a triage to get it started, make sure your question goes to the right person. So the resources for today, we're really, if we get this, well, we will get somewhere, we're going to focus on the exercises after I get to the point of asking your questions. But these are all useful links. This is the code base. The Rfun flipped code base is the code base for today's workshop that you may have already looked at. The exercises will be supplementary to that. The Rfun site is just a branded site of just the R workshops, and then you can find out everything else about our services at this link. One more comment about, and I'm almost done with the introduction. One more comment about getting your questions answered. The R community is known for being helpful, and as such, they have sort of introduced, I don't know as I would call it a standard or even a convention just yet, but it seems to be gaining traction, this concept of reprex, or reproducible examples in code. And what I want to promote to you is this is the most efficient way to get help on your question. You can go to that link and learn more about reprex. There's even a package that will help you turn your question into a reprex question. But in short, let me put it to you this way. Nobody wants to receive 500 lines of code and have someone say, somewhere in there I have a problem, right? Or even, in the third subroutine, I'm not sure why it's not working. So the concept of reprex is reduce your question to its smallest, most reproducible element, and then include only the code that needs to run it and the smallest bit of data that will reproduce the problem. I will caution you, and I'm sure you all know this, that if you're posting questions to internet sites and you have personally identifiable information in your data sample, of course you want to scrub that out. But the idea is to reduce this all to a very small, easily reproducible problem so that you can get a solution. I guarantee you that you get much quicker answers on the internet when you do this. It's a great technique. I am also sympathetic that if you are brand new to R, you may not really have the tools to create that reprex. So I'm happy to get any kinds of questions, and I will probably ask you to do things like make it reproducible. But feel free to say, hey, I'm just brand new here. I don't know what I'm doing, and I'm a little bit lost. And I'm very sympathetic to being new to programming languages and feeling a little bit lost. So help me help you, and we'll figure out an answer to your question. All right, this is the end of my slide deck. Just so you know, this slide deck is actually available. I'm going to go back 2 slides, 3 slides. If you downloaded this code base, the slides are in there. They're buried in there, but they're in there. And this is just one more example of what R can do. This is pulling your survey responses. So there's a left side and a right side to this survey. The left side is the pre-survey responses, and the right side is false, because there have not yet been any post-survey responses. So I just basically doubled up your answers and put them both on the same side. But what you can see across each row is the different aspects that I'm going to cover today. So my questions to you before the survey is, how comfortable do you feel about these different aspects? So in terms of importing data, the majority of you agree that you feel comfortable with that. And I'm hoping that in the post-survey that what I will see, so I can judge my effectiveness, is that there will be less brown in this survey and more blue, and that I'll be moving all of you over to that blue side. So that's just a little plea to say, I hope you did fill out the pre-survey, and I hope you'll fill out the post-survey. I was delighted that I got a 50% response rate. Thank you so much for all that you have gone through just to be here today. I know it feels like a lot. That said, let me comment on what we're going to go doing going forward. I'd like to open up for your questions, but I want to start off with a quick reintroduction to how you can use R in a reproducible manner by creating projects and scripts, and we're going to do a quick data import. So it's really these 4 things. And if you'll bear with me, once I get that done, I want to open it up to stuff that you maybe didn't understand in the videos if you watched them. Now I need to move my screen around here a little bit. Why is this not working as well as I want? Here we go. Put that over there. And I'm going to use Zoom to connect to a virtual computer. If I can find it, where is it? It's not there, it's not there. Where did my virtual computer get to? Did I turn it off? No. Ah, it's right there. Oh, I've got more windows than I realized. Okay, so this is my virtual computer. I hope you are seeing at this moment just a blank blue kind of baseline Windows screen. If you are, then we're in the right place. If you're not, maybe throw something in the chat so that I can correct that.
Yep, looks good.
All right, great. So like I said, I'm going to try and cover sort of these basic aspects of reproducibility, scripts, projects, and import. I'm going to start off by clicking on my RStudio. Again, RStudio is a mask that sits on top of R. For this workshop, I downloaded the very latest version of RStudio, and it has a really nice new feature in it that I would like to mention and I'll point out to you. But in case you haven't seen R before, this is RStudio sitting as an interface on top of R. And on the left-hand side is the thing that we call the console, which is really the direct interface to the R kernel. So you can put in, and that makes it really just a big calculator. You can put in just any kind of math and get a response. Or you can do basic R activities, like let's say I'm going to create a vector of character names. So I'll create a vector called names, and then I'll use the conventional R assignment variable, which is a less than and dash symbol. And then I'll use the concatenate. I think that's concatenate. I forget what C stands for actually, but let's say it stands for concatenate. I'll use the concatenate function and I'll add my name. And I'm going to pick out some names that I see. Hyro, and I'm just going to do 3, and Heather. And so if I do that and I hit enter, what happens is nothing seems to appear here, and that's because I have the assignment variable. But up here in my environment tab, I see that I have a new object name, and it's a character string of 3 elements, and it's those 3 elements. If I wanted to see that, I could just type names, and when I hit enter, I'll get the value of that particular object. Okay, the thing is, if you string together a whole bunch of commands like that, it's not very reproducible, and the minute your data changes, you have to go back and remember all the steps you did, and that's why in R we use scripts, right? So a script, easiest way to get started with a script is to click on this little green cross up in the upper left. And if you click on that, you'll get a mini context menu. And you can create lots of different kinds of scripts. I'm going to recommend one way, but I'm not going to say that there's one right way, but I will tell you that I'm very bullish on Tidyverse approaches. So I'm going to create this thing called an R notebook. What an R notebook will do is it will generate this blank code in the editor portion of my RStudio. So I just split that. And what I am going to do probably is I'm going to minimize the console because I don't personally want to keep on working in the console. All right. And what I see here is something that's called, it's an example of something called literate coding. And what literate coding means is that you can combine prose or natural language with code. And so the code exists in these little blocks here. This is one code block or code chunk. And there's prose on either side. And so what you can do with that is you can actually narrate and write your report in the prose part, and then intersperse whatever is needed to generate visualizations and analysis in the code chunks. And you can have as many code chunks and as many prose chunks as you want. Up at the very, very top is just some basic metadata. So a title for this document, and then I can add some, there's, again, basic metadata. You can learn more about this, but I'm just going to put in my name, John Little, in quotes. I usually put in a date. It's easy enough to just put in a free text natural language date, but you can do things like put in backticks and put an inline R function there, sysdate. Now, I know that this might be going a little bit fast, so remember, this will all be recorded. So if something is going too fast, don't fret. And what that would do is pull the system date. Just as I'm saying that, I'm noticing all of a sudden that I feel all the sunlight coming into my room, so I want to apologize to you if my face is too bright or bothering you. I'm working from home and I repainted the room that I'm working in. And I took down the blinds and the new blinds haven't come in. So I have no control over the light. And I may end up like leaning forward so I can see my own screen well enough. Okay, so this is the metadata portion. It's called a Yaml header, right? And you'll see how it works in a minute. Now, everything else is markdown, and it'll feel like old school, like 1970s style markup to your prose. For example, this is a link, and this right here is surrounded by asterisks, single asterisks. That makes it bold, and that word is bold, right? All you need to know about Markdown, you can find out from this link right here. In RStudio, you could actually hold down the Shift key. Oh, well, great. It's not working for me. But I'm sure I just have to reboot. This rarely happens, but it did seem to happen today, which is typical of a live demo. If you hold down the Shift key, you can usually click on that link and it'll pop you into a browser to find out more about R Markdown. But there is an easier way. You can just go up to Help and choose Markdown Quick Reference. And in the Help box, you'll see a whole bunch of information, like how you make words italicized. You can either wrap it in single asterisks or wrap it in single underscores. And bold is the same way, double asterisks, double underscores. You can make first level, second level, third level, fourth, fifth, sixth level headers. You can make bulleted lists, ordered lists, examples here about how you use R Markdown. It's all right there. Normally, when I'm working, I just delete all this stuff off the start. But I'm not suggesting that you do that if you're a newbie. This is all useful information designed to help you. Soon you will have it completely memorized because it's not really that hard to memorize. But you don't have to memorize it because it always comes up. Like you can leave this here until you're done with your report. But what I'm doing is I'm composing a report. So I might start out by saying second level header, executive summary, and I might compose something to my audience saying, sorry, I can't talk and type at the same time. But there's an example of a second level header and some text. And then I'm going to, oftentimes I'll do something like, if it's a technical audience, I'm going to do something like this, import, load library packages. And I'll make another code chunk. I can insert a code chunk right here by clicking on this green button. But just note, again, like I said, all the information you need is right there. This tells you how to insert a code chunk. So I can do that and insert a code chunk right there. And we'll do more of this, but I can type library tidyverse, and you'll see that it's tab completion. The less information I have, the more options it gives me. So I can go down here to tidyverse and hit tab, and that would load my library. And then the other thing I can do is I can execute these code chunks by clicking on the little green arrow, or I can click the run option and run all. Now, why this leads towards reproducibility is a couple reasons. One, like I said, you have all of your code right there, and you have your analysis and your prose there. So take, for example, and so your output then, in this case, would be an HTML notebook, which is a document you can share with somebody, and they don't have to have R. They can see they can see either a polished report or a technical report, whatever. You can change that output variable to slides, to dashboards, to shiny dashboards, to websites, to ebooks, to EPUBs, to articles. I don't know what I'm forgetting, but the list goes on. The point is, you can generate all that from one bit of code. That lends towards reproducibility. So that's something called literate coding and in our notebook in this case. If I was going to change it, I could change it to a PDF file. I could change it to a Word file. So just so you know, I rarely ever myself ever open up Microsoft Word anymore. I just do everything here. You might say, hey, but I don't really want to write in that old 1970s computer style manner. And what I want to point out to you is that there's this new little icon in the latest version of RStudio that says switch to visual editor. So you could do that. I'm going to do it right now. And it's going to switch over to something that you're a little more modern looking, that you're more familiar with, right? So I can use this, and instead of wrapping packages in asterisks to make it bold, I can just highlight it and make it bold. And I can highlight this and make it italics. And I can highlight this and make it a link. And it works just like many of you who are used to more modern editors would come to expect and appreciate. Right? I'm going to switch back because I find that I am still in a space where I prefer the other method. But I want you to know that that's there. So I'm just going to click on this again. If I can. Come on, there we go. Oh, I did it too quickly. I was impatient. Notice that what I did, where I just made the word packages bold, it did this exact thing. It wrapped that in double asterisks. I made RStudio italicized, so it wrapped that in single asterisks. and I made the word analysis a link, and it wrapped that in the R markdown for making links. So I said that you then have pros and you have code chunks. I'm going to execute this code chunk by clicking on this green arrow. And by the way, soon I will make my font larger if it's small to see, but I would like you to be able to see the full features of RStudio for a minute. When I execute opening just this Tidyverse package, which is a suite of modern data science-like packages, what it's really doing is it's loading 8 packages at once. Now, there are 2 things about packages. Sometimes you install them, and there's a command for installing them, but I will just point out over here in the bottom right quadrant where it says Files, Plot, Packages, right? I can install from here. I can click Install right here, and I could type in Gapminder, and I'm not going to, but I could install Gapminder right now by doing that. You only have to install a package once on a machine. You may have to update it, but you only have to install it once. On the other hand, this is called loading a package where you type library. So if I had Gapminder installed, I would also load that. Looks like I do have it installed. And then, no, so you only have to install them once, but you have to load them every time you open up RStudio or every time you open up the script, right? So I'm going to put those at the top, and I'm going to run it. And when I ran that, RStudio came back, or R came back and told me that the Tidyverse package is actually a conglomerate of 8 packages that it loaded. When you install Tidyverse, it actually installs like 50 packages, which are all helpful. But most of them are foundational, and they sit in the background, and you never have to worry about them. But these 8 packages are useful. You've got Ggplot for visualization. You've got Tibble, which is for data frames, keeping your data in a grid format. TidyR and Dplyr are for manipulating and wrangling your data. Reader is good for importing CSV data. Per is good for iteration. So if you want to iterate over a data frame or a list. Stringer is very handy for using regular expressions and manipulating text. And Forecast is a library that is helpful in working with categorical data, right? So factors. The other thing it's telling me is that there are some conflicts because there's a filter function that's associated with Dplyr, and there's a filter function that's associated with stats. And I can use the long format to address either one of these, but what it's telling me is if I just type filter, I'm going to get the Dplyr filter, which is masking the stats filter. All right. By and large, you can kind of ignore this, but it's helpful to know what you're looking at. It does the same thing for the lag. Now, if I have a really technical audience, they might not mind seeing that feedback, but in the context of my report, if I don't want them to see that feedback, I'm going to click on this gear in the code chunk, and I'm going to turn off my warnings, and I'm going to turn off my messages, and I might even choose this option where it says show output, and choose show output only, where it doesn't even show the code chunk. But I'm going to make those decisions selectively. Some audiences in my reports will want to see the code chunks and the analysis, and some audiences won't. Okay, so it makes some changes up here in this line, and I can click that, I can run that again and get a different kind of output. Here's a different example of a code chunk. It's taking the cars data set, and it's making a scatter plot out of that. This is an example of base R visualization. By base R, I mean not Tidyverse, the stuff that comes with R. And so when I execute that, I get an inline visualization of a scatter plot. All right. When I save this, I might do one more thing. I might change the title of this document to Hello World and click Save. Or actually, I'm not going to click Save. I'm going to click Save up here, and it's going to let me move this. I'm going to go from Packages back to Files down here in the lower right-hand quadrant, and I'm going to click Save, and it's going to prompt me to give it a file name. So I'm going to call it Hello World 2 because it looks like I've already done Hello World. And when I save that, if you look real closely down here, what you'll see is it will make a derivative report. So there's Hello World, then it made the derivative report, and here's Hello World here's hello world 2, and here's hello world 2.md.html. So if I click on that, I can open it in a browser, and it's in a web browser, but you can send that complete HTML document to anybody, and as long as they have a web browser, they're going to be able to read it. Again, if I go back to this notion that I can have different kinds of outputs, maybe I want to create a PDF document and send that to them. Maybe I want to create a Word document and send that back to them. I'm sorry for being so late to looking at the chat, but it looks like for this workshop, are we using R Markdown or R script? So we're using R Markdown, and Drew answered that. So thank you, Drew. Okay, I don't have to worry too much. And the reason why we're using R Markdown is going towards reproducibility and demonstrating literate coding, right? And so going back to this sample report, right, this is something that I could send to a non-R person, and they could read it and see the output. They may not be, again, they might not be interested in this technical aspect, but they might be interested in just the chart. So I could send them that report. All right, I am almost done. I want to talk about projects here real quickly. A lot of old school R people are in the habit of using two commands a lot, and they'll put them up at the top. They'll put set wd, and here they'll put in a idiosyncratic file path to something. And they'll also run this command. And if you're not an old school, if you're learning, don't memorize this. My comment here is don't do this. And they'll also do this, rm equals something like this. I do this so infrequently that something that's not exactly correct. But the idea behind this command at line 10 is that you're cleaning out your environment variable. And the idea behind the command at line 9 is that you're setting the working directory for your project. The problem with both of these is they're not as effective as you want them to be in a reproducible context. For example, setwd means that if you move to any other computer, and you will upgrade your computer someday, it's unlikely that your new computer will have the exact same file system as your old computer, which means all of your scripts minimally have to be updated right there. If you use RStudio projects, you'll never have to do that, and you can refer to data through a relative pile structure, which is a preferred reproducible approach. Similarly, they're using this to clean out the environment because they want to start from scratch every time. But what I'm going to do is I'm going to comment out each one of these so they don't run. But in an RStudio project environment, what you would do is you would just go run all, and you could always do this one first. You could just restart. And in this case, I'm going to clear the output so you can see how this returns it back to normal. And then you can go back to run all, and it'll run the whole thing. And what you're certain of is that if you can clear your output and restart and run all, that you have a reproducible script, assuming you've used relative file paths. You can share that with somebody else on GitHub. You can share that with your boss, your colleague, your coworker. You can share it with yourself, which is something I do all the time. I have one computer at work, different computer at home. So that's why you want to use projects. And the easiest way to use projects is to go up here where on the upper right where it says projects and click new projects. All right, this is asking me to save something, just save the latest version of this unsaved document. So I'm going to click save. And it's going to give me a dialog box here in a second. And you can see you can choose different ones. If you're using version control, you can pull projects directly from GitHub. I'm just going to do a blank new project. You can also start book down projects, which is to generate ebooks, or start websites, different things. I'm just going to do a blank project. By default, for me on Windows, it's going to put it in my documents directory. So I'm going to say, I'm going to call it dinosaurs, assuming that I have some project where I'm evaluating dinosaurs. Right, and what it does is it creates a different view of RStudio. You can have multiple RStudios running at one time. They won't bleed over each other. They won't share the environment. So you're not gonna have any danger of accidentally having the same variable name, that kind of thing. And then it starts with only this one file. That's the project file. So I'm going to close this real quickly, if you'll keep up with me. I should not have closed that, and I hope to be able to restore all that. Yeah. Oh. If I look in my file system under Documents, here's my Dynos project. And it has my R history and this one other file, R project file, which is really tiny. And all it does, if you double click on it, is it'll launch you right into that RStudio project. All right. So in a minute, I'm going to cover one more aspect of importing data. But I want to pause here because I've talked kind of fast. I want to make sure we all have the same introduction to how this environment can work for you. And I want to give you all a chance to ask questions. We can literally, I'm happy to go straight into questions that, general questions ideally, that were unclear in the videos that I sent out, or that you ran across some of the exercises and something didn't seem to work right. And I would love to pause, just unmute yourself and start asking your question ideally, or if you want to, you can put it into chat. And see if we have any questions right off the bat. And that can include the stuff that I just covered.
I have one, John, about the oops, sorry to interrupt. Can I go ahead?
Oh, please do. Sorry. Thank you, Ellery.
Yeah.
Please.
It's
please
about the first practice exercise.
Yes.
Specifically about using the left join function.
Okay.
So when I try to run the left join function, I'm getting the error that join columns must be present in the data, and there's an error in calling the data by name. So I'm wondering, is that an error in the way I'm running the function, or does that have something to do with the way the favorability CSV file was set up? If maybe I'm calling it wrong or something like that.
Right. I'm with you. Just to make sure I understand, are you in this file exercise_01? Or in a different?
Oh, this is a separate notebook I set up from the part 1 video.
Oh, I see.
Yeah.
Okay. Let me see. Let me just open up a couple files and make sure I have some good examples of. I don't quite know the answer to your question because I don't understand. Here's one thing that's really true about R is that it has some horrible error messages. And a lot of times you just stare at them and go, I literally have no idea what that's supposed to be telling me. And so what I'm looking for is my example of left joins. And I know I have one. So I'm going to go down here, find in files and type left join and see what RStudio comes back and tells me. Oh, good. There's one in Quick Start. But I don't know if Quick Start, I'm surprised that. Oh, I think I know where I want to be. I'm going to switch to a different project. Intro to R. I think this is the one I want. Yeah. Let's try that. Okay, double click on that. Could you tell me, Ellery, could you tell me the error message again?
Yeah, so the context of it is we're using some functions from dplyr, and we are trying to join the favorability data onto the Star Wars data. So
Yeah.
the line specifically is calling the left join function to join favorability by name. And the error message
Right.
I'm getting says join columns must be present in data. So
Oh,
yeah, I was thinking maybe
okay.
it had something to do with
So
the favorability data, because that was the one that we referenced by the URL to the GitHub repository.
it sounds to me like you have two data frames. I really wish that I could find a good example. And I'm embarrassed that I don't have an example handy. But I'm going to find one. I'm going to go here, and I bet I'm going to be able to find it there. It sounds to me like one of your data, in order for a join to work, you have to have a key that is the same variable in each data frame.
Okay.
And the same variable has to have, in order for R to figure it out automatically, that variable has to have the same name in each data frame.
Okay.
Now, you can manually override that, and you can say, I want to join hair color with weight. And so anywhere where hair color equals blonde, if weight equals blonde, which I know this doesn't make any sense, but if it can make that connection, it will then join data. However, without seeing the full thread of what you did, since you made your own kind of example in your own editor, it would be probably, there we go. There we go. That's exactly what I want. O2 join skimmer. So I'm going to just demonstrate it here. So in this example, I'm going to load two libraries, Tidyverse and skimmer. We're not going to get to skimmer. But the first thing I'm going to do is I'm going to read in some data. And in this case, I'm skipping 11 lines of data, because the first 11 lines are a provenance of the data set, which actually came from 538.com.
I don't think that we're seeing your screen.
Oh, thank you so much. Whoever said that, thank you for, let me get back here. All right, you should be, when I click share, you should be seeing a blue screen.
Yeah.
Dark blue screen.
Yeah,
Right, so I ran these two libraries at the top, and then I'm gonna read in this data using the read_CSV function. And that's an example of referring to the data relatively, because all I had to do, since I'm in an RStudio project, all I had to do was refer to the directory. So I'm going to expand my screen. And what I mean by that is relative data file naming. This is the data directory, and in the data directory is the 538 file that I want to read in. So by using that relative path designation, it becomes more reproducible. And then I'm giving it one argument. Let me minimize this. The skip argument, which is skipping the first 11 lines, because if we looked at this data raw, which I think I can do, view file, you can see that the first 11 lines are just telling me where the data is coming from. So I want to skip all that stuff. And when I run that, I'll get then an object in my environment space that says favorability popularity rating. Wait a minute. Why is it not in my environment? Oh, because that wasn't on the right tab. And I know that this is now a data frame. It has 14 observations and 2 variables. If I click on this icon right here, I can actually get a data viewer that will allow me to sort of preview it. But I personally generally don't do that. I generally, if I really want to see the data, I'll just use this same object name again below it, and I will just display it below. So there's my favorability rating data. It has 2 variables, name and fav rating. Now I'm also going to use this Star Wars data, which I didn't have to import because it's on board. It comes with the Tidyverse. Specifically, it comes with dplyr. And the Star Wars data is 87 rows of information about Star Wars characters, right? And so in this join, my join key is name. And you'll see that my variables have the exact same spelling It leaves nothing to chance. And what that means is if Luke Skywalker has a variable in this other data frame, Luke Skywalker from Star Wars matches Luke Skywalker in the name variable from favorability rating, then it's going to pull over this value of this column or all the other columns. Depends on how I make that work, right? So let's go back down here to the join. Happened right here. So the way I read this, if I read this from left to right, and we haven't gotten through all this, so some of you bear with us, is I've got a new object name, SW_joined, gets value from, that's the way I read that in my head, that's an assignment variable, gets value from Star Wars, the onboard Star Wars data set. This is called a pipe, which means I can read that in my head as and then. So Star Wars and then do a left join with this other data object, which happens to be a data frame. And then in this case, I don't have to name both columns that are the key because they both have the same name. So if I run that, just that part of the command, which I can do, I can highlight that and do Control Enter. I now have one additional column. Instead of a 14-row column in Star Wars, I now have a 15-row combined column. And I can scroll over to the right, and you can see a couple of those joins were successful. And the ones that weren't successful, I got NAs, or not applicable, not available. There's a few more Tidyverse commands going on here. But what I would say to you, Ellery, is you probably, give me a second here, and I'll show you how I would solve this problem. Is I would hit F1. I would first figure out what are the join columns between my two tables, and do they have the exact same spelling? If they don't have the exact same spelling, I'll either make them the exact same spelling by doing something like Star Wars rename, let's say rename type equals species, something like this. And that's going to rename the species variable to something called type. Like we can see that in action right here if I just display this. Oh, it put it at the end. Or it didn't. Where did it put it? Why am I not seeing it? There it is. It put it right there. So I'm either going to rename it or I'm going to explicitly call out those two issues. So I'm going to highlight left_join, which is my function, and I'm going to press F1 because that's going to make it easy to find my onboard help. And then I am going to look for the answer for how do I want to write that in the examples. And actually, it doesn't appear like there's a good example, but there might be an example down here. Pretty certain I know how to do it, but I'm wondering if I can. This is, by the way, this is very typical of how you use R. You will get exceedingly adept at typing, how do I join tables with a left_join function, and then use the phrase in R or with Tidyverse. And then you'll get back a whole lot of useful information. But it would look something like this. I'm not seeing it right off the bat. I'm probably not reading. Oh, here it is right here. Oh, yeah. So what that's saying is, in one table, the join key name is going to be matched in a different table with the join key artist. And they're going to have the same value. Okay, so that's probably what's going on there.
Yeah, I took a look at it. Yeah, sorry. I think the problem was the favorability CSV, I think, was maybe read wrong from the GitHub repository. There's no name section in it. So that totally makes sense because it can't find the name. So I have to go back in and make sure that it's reading that file correctly, I think.
Yeah, you might need to employ the skip argument because of the way that file exists. And by the way, I am more than happy to either, if you're staying around till the end, we'll drill down on that specifically, or we can do a consultation and cover that more at some other time. It's important to be able to join data frames together. Okay, so
John, before we move on too much, we had a couple of folks had questions about if you could go over the difference between sort of our notebooks, our Markdown, our scripts, and our projects, just for people that
Yeah.
maybe are only used to using the R script.
Okay, so let me see if I can go back to my other cloud computer. So in our Markdown is, let me explain it this way. For people who are used to looking at web pages, you see pretty web pages. But if you ever view source on a web page, you see a whole bunch of stuff that is not so pretty. So if I go to Wikipedia and I click on, I'm trying to find a place to click, right-click View Page Source. This is the stuff that makes that page possible to be rendered as a pretty page. And it's called HTML, or Hypertext Markup Language. So markup language, there's all kinds of markup languages. There's SGML, there's XML, there's HTML. And Markdown is a markup language. The reason why they call it Markdown is because it's a simplified markup language that allows you to put structure to a document so that you can have things like bolded words and italicized words. And the reason why we're doing that at all is because I am wanting to teach you a method that is called reproducible programming with literate coding, right? And so literate coding is this idea that you're interspersing prose or natural language with code chunks. And in that way, when you have those two things interspersed, you can actually write your whole report from here and then generate the output of your report by choosing a different variable right here. So if I want this report to be a report to an executive, I'm going to put executive summary. Cars are, I should probably capitalize that because it's going to the executives. Cars are unsafe at some speeds, right? And then I'm going to say visualization, or I'm going to call it chart. Here's my evidence, right? I'm writing myself a report. I'm writing a report for my executive audience, and I'm going to then do my analysis. I'm skipping the part where I import my data set, but just so you see, if I typed in cars, this is another onboard data set. It's a really simplified onboard data set. Two variables in a data frame, speed and the stopping distance, right? So if I want to show my executive this chart, but I don't want to show my executive the code for that chart. I'm going to click Show Output Only and apply that. And then I want to make that a Microsoft Word document because my executive doesn't like all the other fancy stuff I'm doing. So that gives me a chance to rename it. So I'm going to call it Cars Report and click Save. And it should put it right there. And actually didn't do what I intended. It gave me the option to create two different kinds of reports, and it created one. So I'm going to go back up here and choose Knit to Word. And now I've generated two different reports. I'm going to minimize this for just a second. You can see that I have two different rendered reports from a single script. I have an HTML notebook report, and I have a Word document. And then I can send this Word document to my executive. And so that's the simplest use case I can present to you. There are much more complicated use cases. But the idea that all of my prose and my analysis are all in one single file means that when my data changes, I don't have to rewrite the whole report. I don't have to output my visualization into some different visualization editor and then copy the visualization editor and then paste that into Microsoft Word. All of those extra steps of clicking and pasting and copying, those all break down a reproducibility chain, right? Because you can't document, click here, right? Well, you can document, quite honestly, you can document it and you can script in a visualization context. But the state of the art really has come to accept that reproducibility works better in a command line context. So that's why we do these kinds of things. That's why I'm promoting it. So I don't want to say that this is the only way to use R. If you really prefer R scripts and all you want is the R script in your code, go ahead. What I will tell you, and for those of you who don't know what an R script is, I guess I'll show you one.
Can I ask a quick question before you move on? So whenever
Yes.
you generate that Word document, if you were to go back at a later time and then update the data somehow with more cars reports,
Yeah.
and then you save that and click back onto this first generated document, will that automatically update if you run all the script again?
Yep. Yep. So let's do this.
Oh, wow.
Let's say that, let me go back here. I will do exactly what you said. I'm going to update my data, but I'm just going to update it in real time. And I'm going to do it so that my executive audience doesn't see it, right? I'm going to take my cars data set. I'm going to say new cars, gets value from cars. That's my original data frame. And I need to take a quick peek here at what I'm doing because I don't have the variable name memorized. So gets value from cars, and then, that's this part, and then speed, oops, I need my mutate command. Mutate speed equals speed. All right, now I'm going to make this up if you all will forgive me. But let's say that that speed is in miles per hour and I want it to be in kilometers per hour. And I grew up in the US and I can't do these. If anybody wants to unmute and tell me what the formula is, shout it out. But I'm just gonna divide by speed divided by 0.8 and hope that that's sort of, I don't even know what it is. I mean, I'm so not thinking this way, but let's just run this and you can see new cars. I'm gonna comment that out for a second and I'm gonna re-execute this command. What did I do wrong? Cars, oh, I spelled mutate wrong. Perfect, mutate. I myself am a horrible speller. And for some reason, I really probably need to restart this, but I'm afraid that what will happen. It's not working as smoothly as it usually does. What else did I do wrong? Mutate. Could not find function pipe. Oh, that's because, oops, I forgot. I haven't loaded my Tidyverse library. And so I'm doing some really, what I'm going to consider ugly code here is that I'm doing it all in one code chunk. But bear with me here. I load my Tidyverse library by loading, and I loaded my Tidyverse library so I could use my mutate function because mutate is a function within Dplyr, which is a package within Tidyverse. And now I have this new speed, right? So, so effectively I have new data. I just made it up. And I'm gonna take out that command and I'm gonna run this execute and I get, it looks like the same plot as I had before. Oh, wait, what I want to do, let's make two plots. Plot new cars. And so I'll have some, what I'm going to do is I'm going to say, I'm going to make two code chunks. And I'm going to say, here's my evidence when speed is measured in MPH and evidence when speed is measured in kilometers per hour. Right now, if I go up here and I click run all, I have two charts. And the only difference is, wait a minute, that doesn't look right. Oh, let me double check my, golly. I tell you, live coding, you're probably learning something. I'm going to make this a little, I'm going to change this mathematical formula so it's really, really clear to me. So rather than divided by 0.8, I'm going to multiply by 20. And that should give me, yeah, there we go. There, it's really clear that I have a different unit going on here. All right. So all I did is I generated some new data and I generated a new graph. And then when I knit my Word again, it's going to re-render that. And now I have my report without any of the technical. Why did that look that way? I'm going to do it one more time. Oh, I forgot to turn off my library warnings, but I have my 2 reports. So I hope that answered your question. That's the idea of a reproducible workflow chain. This is great. I'm glad you guys are asking questions. I know I'm going to have some people who want to get into the guts of it, but if somebody else has a question or a follow-up or haven't explained that part well, let me know. We're just about been doing this for an hour. We've got another hour that we have available to us. So I like to be patient just in case somebody's trying to decide if they're going to ask a question or not.
Yeah, John,
By the way,
I hate to
yeah.
I hate to get too into the weeds, but from your perspective, so if you're working in, say, Tidyverse and you also want to do some stuff with another library called Data Table, do you want to keep it all in the same idiom, or is it okay to mix and match different libraries?
It's totally okay to mix and match different libraries, and that is the nature of that comment I was making before. I don't know if I can reproduce it, but when I loaded the Tidyverse library, down at the bottom of the feedback, it said that dplyr filter was masking stats filter, right? So you can have, the whole point of having libraries is extending your R into various realms. And the Tidyverse is a very generalizable realm, but you may have an expertise in some kind of modeling. And so there's another package you want to bring in, and you want to run those at the same time. Now, the data table package does some things that are similar to what Tidyverse does, but you should be able to run them both side by side. You just have to keep a lookout when you run them, when you load them. Are there any conflicts that are preventing me from using a possibly identically named function? But even still, just because there's a conflict, it only means that it's masking the short version or the convenient version of the function name. So if I typed, when I run Tidyverse, I no longer have access to stats filter. But if I start a new code chunk right down here at line 36, and I can still access stats filter just by typing the long version, which is to first identify the library and then 2 colons and then filter, and then whatever the arguments for stats filter. So you can use them both. Just have to be more careful where there are those kinds of conflicts. Great question. All right. So I'm really glad that you guys are jumping in there. What I'm going to, and I'm still open to anybody jumping in and asking another question, but what I'm going to propose also is, while I'm waiting for that other question to come in, is that when I move forward, I will do one more quick demo on how you can leverage that relative path and project concept when you're importing data, and show you some tips about importing not just CSV files, but Excel and Stata and SAS. There's a really nice import wizard that's worth knowing about. Excuse me. And then if there are questions there, we'll deal with those. And then I'm going to move into some more specific questions about the dplyr package, that sub-package of Tidyverse, which is all about data wrangling. So how do you subset rows and columns and create new variables like I did earlier with mutate? All right. So what I want to do is I'm going to switch to my web browser, and you are welcome to follow along with me. I am going to go to this particular new repository that I've made and put up on GitHub, just intro exercises. Now I'm going to put this link in the chat. So you can click on that or save it for later. But what I'm going to do is I'm going to show you I'm going to show you the never fails, always works way of getting code from GitHub. There are more convenient ways to use RStudio and GitHub, but we don't have enough time to go into how you configure that. But what this is, GitHub is a way to share your repositories, or if you'll think of it this specifically, your R projects, so that somebody else can grab them. Now you can make them public so that anybody can grab them, or you could make them private and designate who else can look at them. But this is a public repository. It consists of these files that you see here, plus this folder called data, which we could click through. And it has, in this case, a README file. And I want to download all that and manipulate it. You'll notice, by the way, that it has an rproj folder in it. So when I launch that from rproj, I'll be able to be in a special R project and leverage the values of an R project. So I'm going to click on this green button here that says code, and I'm going to download zip. Again, people who are more used to using RStudio will know that, and GitHub together with, for example, a package called use this, will know what to do with this stuff here. We're just going to do it the never fails way. I'm going to click download zip. And in my computer, that created a zipped file somewhere on my computer, which I know from experience is going to be in the downloads folder. I know on a Windows machine, I can just click on that and go straight into the downloads folder. And here I have a compressed file that has, this one compressed file has all of this stuff in it. And it's important in this never fails method to expand that zipped file. I think on Macs, you can probably just double click on the expanded file and it will expand. I don't use Mac, so I'm not 100% certain, but at least on Windows, it's very important that you expand it, because while I could look into that expanded zipped file, I actually want to expand. I don't want to just look into it. I want it to be expanded so I can write back into it, read and write from it. So I'm going to right click on that. And I'm going to click on extract all. And Windows will give me an option of where to put that. So in this case, I'm just going to put it on my desktop. And I'm going to, I guess it's going to give it whatever name it gives it. Click extract. Okay, and then it opened up a new folder for me. But let's just do something here. I still have the zipped file, and then I have this file. I'm gonna minimize everything and just look at my desktop. It's right there, and when I open it up, there's all the files that I just downloaded. And what I want to do is I want to open this as a project. So I'm going to find this R project file, and I'm going to double click on it, and that's going to launch me directly into RStudio. And it's already set the working directory so that I can do things like I'm going to do just now, which is an example of importing data with a relative file path. So if I open up a new project and start down here, I'm going to put in a new code chunk. I'm going to use the code chunk keystroke, which is mentioned right here, Control-Alt-I. And I'm going to say my data. And then I'm going to do Alt dash to do my gets value from command, but you could type that out. My assignment variable gets value from, and I'm going to use, oh, I got to stop. I already realized I've gone too fast. We do this all the time. I'm so used to using Tidyverse that sometimes I forget that I have to load the Tidyverse first. So I'm going to insert another code chunk, and I'm going to try and use some brief examples of literate coding. Load library packages. And I don't have any pros here, but if I did, I would put something like the Tidyverse is a great data first set of packages. And then I'm going to load that package, Tidyverse. And then I'm going to run that package. And I'm not sure if I'm going to get any feedback this time. I did. That's fine. I'm also going to just click that little X that came out. Tidyverse is only verbose on a kind of an initial basis. I'm also going to, for me, I'm going to get rid of all this stuff because I would encourage you when you're new to not get rid of it off the bat. It's helpful information. But I know what's there. So now that I've got the tidyverse loaded, I have access to my pipe function, which I can access by typing Control-Shift-M or Command-Shift-M on a Mac. And all that pipe function is a conjunction. It allows you to string together a sentence, if you will, of R functions. So I'm going to read this almost from left to right. Oops, I didn't actually mean to do that. Ignore that. We'll come back to pipe. Now that I have, sorry, I shouldn't. Now that I have tidyverse loaded, I can use the tidyverse version of reading and data. So if I type read and just stop, my context menu pops up with read.csv. And what I'm going to tell you is there's a sort of a visual cue that if it's a dot, it's not part of tidyverse. Now you can use this to read in a CSV file. It's from the utils menu. It says right there, utils, and it gives me some brief help on how to use this function. But I want to use the tidyverse version, so I'm going to put in an underscore, and it becomes the second option, and I'll just choose that. And the technical reason why is because read.csv, and this actually recently just changed, but it changed because they're following the tidyverse lead at kind of our mothership. They're following the tidyverse lead. Tidyverse made this change a long time ago, is that they, by default, do not read strings in as factors. So if you happen to work with categorical data, that's a really important thing. And many people have come to decide that the factors, using factors as a data type is often more hurt than help. I don't want to get into it too much. I just want to say that I recommend to you, unless you're really, really fond of using factors, that this is a better way to import data. Read_CSV is better than read.csv, but neither one is wrong. One's just a little more modern. All right. So then I'm going to type my single quotes, and RStudio automatically put in the opening and closing. I'm sorry, I typed double quotes, and RStudio automatically put my cursor in between the opening and closing double quotes. And then I can hit my tab key, and it will give me a context menu of the file system, the relative file system based on the RStudio project. And so I can just scroll down and choose the data directory. And it's going to give me another context menu. And in this case, there's only one file in there, durhamsupermarkets.csv, right? If I go into this data directory down here, it's right there. All right, I'm going to put my cursor back over here, and I'm going to hit the tab key again. And since there's only one file, it filled it out. All right, that is how I would want to read in a CSV file and write the script in a reproducible fashion. So when I execute this code, you'll see up here in the environments variable, I'll get a new object called my data up here. And it tells me that it's an object of 84 observations and 26 variables. And if I want to look at it, I can put in, another code chunk, and I could write down my data and hit Control Enter. And I've got this big data set here that once again has some stuff at the top about provenance that I put in there. I personally stuck that in there so I would know where the data is coming from, but it makes it a little harder to read in, and it's not exactly in the format I want. So I'm going to show you this thing about data wizards, data import wizards. They exist in kind of two places. One is, generally speaking, under the environment variable, there's this thing called import data sets. And so from here, you can import text data either from base R or from Reader. Reader is the tidyverse. I would always recommend the tidyverse over the base R. Or you can import an Excel file or a SAS file or a Stata file, anything like that. That's one way to get that. The other way is just to navigate into, I'm going to click on this little icon so I get back to the project root. And I'm going to navigate back into the data folder. And I'm going to left click on the file, and I'm going to click the import data wizard here. It's the same data wizard. I just find it more convenient to get to it from there. And what this does is throws me into a data preview window and allows me to make some changes because I want to skip line 1. I want to use this line 1 as the file headers. By the way, this data comes from the Open Durham data portal, and it is some information about supermarkets and convenience stores. So I'm skipping line 1. I'm going to go down here to skip. I'm going to put in the number 1, and I'm going to hit tab, and it's going to redraw this data frame with the actual data labels or variable labels as the very first thing. And then what it does is it gives me this really nice view of all the code I would need to paste into my R Markdown script or my R script in order to run it the same way every time. Now, I will tell you that you can click import right now and that will work. But I've lost, if I click import without doing anything, I've lost this code only temporarily. So a convenience is to copy and paste it. Right? I can right click and copy. I can click on the clipboard icon. I'm going to click import. I'm sorry, I'm going to click cancel because I already copied that into my buffer. And I'm just going to paste it right here. And then I'm going to tell you what I'm not going to use out of that, right? I am not going to use that because it's redundant, because it's one of the 8 libraries that shows up when I do Tidyverse. But redundancy doesn't really hurt anything. If you left it there, it wouldn't hurt anything. And I'm also going to comment out line 21 because all that's going to do is throw it up into a data viewer that I don't personally ever use, but it's handy to know that that exists. So this command here and this command here are almost identical, different object name that I'm loading it into. And I'm really doing it because I just wanted to remember this one little bit of syntax that I probably wouldn't remember otherwise, which is to skip 1. So now, if I execute these 2, I now have 2 objects in my environment pane, and they're both the same because it read in the data file twice and just gave it different object names. So now I'm going to scroll down here, and I have my data, and I also have Durham supermarkets. And if I execute that code chunk, you can see that I now have 2 inline viewable data frames that are visually, they're visually identical. And in fact, they are identical. So you don't see any difference, but I can scroll to the right, scroll to the left, and I can get through the first, I think, 1,000 rows of any data frame that way. If you're working with really big data, it's going to chop that off because it loads it up into memory and you don't want to bog down your computer.
John, there's some questions in the chat about if you could maybe go through that process of getting to the data viewer again.
Sure, I think, and please re-ask if I'm not asking the right question. Oh, you're talking about the import wizard. Yes, in the import wizard. All right, let me do that again. Once again, I'm gonna click on this little icon right here, which brings me back to the project root. Now, if you didn't open this up as a project, like if you're doing this on your own and you didn't make a project, this icon's not gonna work. But let's ignore that. Most of you, assuming you clicked on the R project file, you're gonna be exactly where I am. And what I want is I want to get to the data wizard, and I know that my data is in this data folder. So I'm going to left click on the data folder, and I'm going to left click on the file that I want. And that gives me a context menu where I can find an import data set. Now, I always like to point out that it's the same access to the data wizard as what you will find up here in the environment tab. But the environment tab allows you to manually kind of make a determination over what the file type is, whereas this is going to do its best guess based on the file extension. So I'm going to go to the import data wizard, and there I am. I'm in the data wizard. I can change the name of the object that it gets changed into, and you'll notice that this code gets changed dynamically. So I can call it foo, and I can decide how many lines get skipped. So 1. I could change the delimiter. Maybe it's tab separated data, which it's not. Of course, now it's not properly read in, so I'm going to change it back to comma. But as I change all those things, all of this code preview changes dynamically with me. And then I'll just copy that. And in my practice is to paste that back into the code chunk, because it's a really easy way to generate the sort of I'm going to say syntactically verbose code that I never seem to memorize, right? So then once I paste that in, I just personally start getting rid of the stuff I know I'm not going to use. And I can run this again, this code chunk one more time, and now I'm going to have 3 objects that are all identical because it's all reading them from the same file. Good. All right. So I'm going to click on this icon one more time, and I'm going to go to this file called O1A dplyr. And Marcos, I don't know if you meant for your microphone to be hot, but my eye just caught a glimpse of your screen with a green thing. Yes. So if you have a question, go ahead and shout it out.
No, it's not a question. I just wanted to thank you out loud for doing so. I think this process that you just went back through again really was very helpful. So just wanted to thank you thank you loudly. So thank you very much for that. Just wanted to do that. I appreciate that. Thank you.
I'm glad to help. You're very kind, Marcos. It is my goal to make this understandable for people who are when you first approach R, it can feel like a tangled mess. So I'm glad that was useful for you. All right. So, all right, I'm going to go to this file, unless somebody else says something, o1a dplyr.rmd. That's the R Markdown file.
Can I ask a quick question?
Zoe, do you have a question? Sure.
Yeah, I do. You don't have to walk me through how, but maybe just a point in the right direction. If you're working with survey data from Qualtrics or Redcap or something, often if you export to a CSV, it'll give you many, many rows of metadata in the first couple. Does this have a way to automatically assign if you skip, say, 4 rows? Or is there a helpful way to link those as labels? Yeah,
as a matter of fact, I was actually demonstrating that. This skip function, you may be asking specifically for a Qualtrics formatted data rather than CSV data. So 2 answers. One is, there is a skip function. Go ahead.
Oh, I was just wondering, I guess if I had 4 rows, it will always link it. It won't just ignore it. It will never ignore the extra rows. It will always link it in some systematic way. Whereas, like, I've struggled with Stata. I think
I think the answer to that is yes. There's sort of, I would love to see an example of what you're talking about because I don't have a Qualtrics data format in my head, although I'm familiar with Qualtrics. So a couple answers. One is there is a skip function that the way I hear your question is how I would first approach it, but I may not hear your question properly. Another thing to point out is that there is a Qualtrics library for R that makes it easier to import data directly from Qualtrics. And I've had, I don't know, 60, 70% success with that. It can be really handy when that particular library is approaching the data the same way you formatted your data and can export it. Qualtrics can be a little goofy sometimes. And then another comment that I would make is data labels can be a real challenge, and especially when you have lots of columns. There is also a package called Janitor, which I personally tend to not use, probably because I'm a little too obsessive compulsive. But what Janitor does is it will clean up all of your file names to variable names to names that are much easier to deal with. Because variable names in this context, in an R context, really in any kind of serious data context, you don't want your variable names to have spaces. You don't want them to begin with numbers. there's a lot of rules about how you can create a good variable name. And Janitor, the Janitor package will help you do that automatically. So I would say to you, Zoe, that probably some combination of arguments for read CSV or the Qualtrics library or the Janitor library is going to help you a great deal. And if you want to set me up with a consultation on that, I'd be happy to look into it more specifically.
That was really helpful. Thank you.
Great. Okay. All right. So once again, I'm going to open up this library or this file, but I want to point out that you could also open up the one that has the same file name but underscore answers, because that one has the answers directly in it, and a report of the answers, so you could just look at it in a web browser. But this is the file I'm going to open: o1a_dplyr.rmd. RMD standing for R Markdown, and it opens it up in an R Markdown document, which will output an HTML notebook, like we've seen some so far. And the first thing I have there is the word dplyr bolded, and some information about where these files are coming from. Now, in my first code chunk, I have this line that says install.packages.gapminder, or not .gapminder, but you can see the syntax. That is the proper syntax. I want to caution you, I myself don't like to put install.package into my scripts, especially scripts I'm going to share with somebody. But in this case, this is usually putting that in there is going to be non-destructive, but you never know when somebody has some kind of dependency on a particular version of a package. And I don't like to overwrite people's libraries if I don't have to. But Gapminder is just a training data set, and if it overwrote your Gapminder, I'm 99.99999% positive that it wouldn't cause any problems. So I left it in there. But again, install packages, you only do that once. You can easily do that from the packages tab. And then loading the packages you do every time you run the script. So I'm gonna execute that first code chunk. It's going to install Gapminder, which is some data, some population data from specific years, from about 1952 to almost the present. I think it's 4-year gaps, 5-year gaps, for across all 5 continents for many, many countries. And we're going to look at it in just a second. All right, so the first thing I usually do when I get a new data set is I use the glimpse command. For those of you who are used to old school base R, glimpse is very similar to the command stir or str or structure, depends on how you want to pronounce it, but str are the letters. And I'm going to execute this. And I find that I think glimpse displays the data a little bit better. Glimpse is especially helpful when you have a really, really wide data frame, let's say 30 or more columns. Because what it does is it lists each column name down this first column. So I know I have 6 columns, sorry, and the columns are country, continent, year, life, pop, and GDP % cap. Now, I want to do something here that I hope will make it a little bit easier. I'm sorry that I haven't done it yet, but there were a lot of things I wanted to show you. I'm going to change the appearance to 150%. I'm going to click apply. I don't necessarily recommend you do this, but you could. I mean, you could, but and the other thing I'm going to do is I'm going to display only the editor column. And I'm going to do that in my case. You can do it with these commands up here, but I know the keystroke is Control-Shift-1. And this is actually the way I tend to work in an R Markdown document, because once I get everything loaded up, all those other quadrants are not so useful to me. So here I have my view of Gapminder. And we're going to now introduce to you, oh, I'm sorry, I wasn't done talking. So 1,700 rows, 1,704 rows, 6 columns. The column names are listed right there. What I get here is the data type of each column. So country is a categorical variable that refers to categorical variable type as factors. And then it gives me a preview of the data, and it's a small preview. Turns out that the first 7 rows are all the same. Continent is similar. It's a factor, and you get in there so far, and then all of a sudden you see a different category. There's Europe as opposed to Asia. Then there's year. It's an integer, so a single number. And there's life expectancy, and it's a double or a floating point, decimal point number. These distinctions you don't necessarily have to worry about when you're new, but it's at least helpful to know that R has a rather precise notion of data types. The one that we don't see here is character. Easily, these first 2 columns could be character, but they're being treated as categories. And those kinds of things can trip you up when you're new, but it's not so important to really get into the details right now. What we want to do is learn how to subset the data, which is how do we take a 6-column data frame and just pick maybe 2 columns? Or how do we take a 1,700 row data frame and just pick certain rows, maybe all the rows where the year equals 1952. All right, so that's what select and filter do. Select subsets by column or variable name, and filter subsets by row, or what we might call an observation. And then arrange allows us to sort the rows by a variable. You'll see what I mean in just a second. So I showed you how to glimpse Gapminder. I can still just look at Gapminder as a rectangular grid the normal way. The only downside I have is it's a 1,700 row data set, and it's only going to give me the first 1,000 rows. So there's another 700 rows here. But that's not that big of a deal, because once I learn how all these different functions, deployer functions, I can become very comfortable with knowing that I'm only looking at a part of the data, but I only need to look at a part of the data, and I don't need to use up all my RAM with the whole data set. I only need to iterate over the whole data set once I get my process in place. Right. So there's Gapminder, and the first question is, how do I subset this by rows? I want to see just the year and the population. And I can see right now that I wrote that wrong. I wrote population as if that's the actual name, but actually the actual name is pop. So, and you can see it right there. There's pop and there's year. And those are the only 2 things I want to see. So I'm going to type Gapminder. Then I'm going to put in a pipe, Control-Shift-M, or you could type that out by hand if you wanted to, % greater than %. I'm going to hit my Enter key. I'm going to type select, and I can use my tab completion, and I'm going to type in the variable names. If I type really slowly, you'll see that after I get past the first 3 letters, it's going to allow me to do tab completion again, comma, and pop. And it turns out that there are 2 possibilities with pop. I just want the one that has the little pink flag, because the other one has a little icon that clearly shows me that that's a data frame, an additional data frame of population. It's not what I want to look at with this one, so tab completion. And when I execute this code chunk, I have subset on a temporary basis the Gapminder data frame to now just be 1,700 by 2 rows. Or sorry, 1,700 rows by 2 columns. It's handy to know, Gapminder, that you can also select by column position, right? So Gapminder, and then select, let's say, columns 2 through 4 and column 6. All right, so if I run this code chunk with both of these, you'll see 2 different data frames. One is the 2 columns, and this one has 4 columns. Generally speaking, I think it's safer to select by name than by position, but you can do both, and you can mix and match, right? I could type continent here, and that didn't work the way I expected. I'm not sure what I did wrong there, but I'm really confused about that. That's what I love about live coding, is it really, I'm not sure why that happened. Year, life expectancy, GDP. I guess it's something you need to look out for. I'm going to go back to, I maybe should have rebooted my computer at some point. It's usually not that fragile. What am I missing here? Life expectancy. Huh, that's a stumper. That bothers me a great deal. It must be because I have I don't know what's going on there. That is definitely wrong. That makes me nervous. So nervous, in fact, that I am inclined to shut this booger down and restart it and see if I can straighten it out. Okay, so I'm going to go back into my exercises. And I'm going to go back into, now this is the problem with having just one screen, is I need to go back to this O1 here. And I'm going to make that one screen again. And then I'm going to scroll down to about where I left off, which was right there. And this time, just like another little tip, I'm going to click this little funky button, which is to run all the code chunks above, which I need to do because I restarted. And I'll get a little progress bar down here while it does that. And then when it's stopped, I know that I can run this code chunk. And I am super confused as to what's going on there. There's something I don't understand about that command. Or they recently updated the select statement. And anyway, I guess it's a good example of you always need to be careful and verify what you're doing with your data. I'm going to move on because the point is that's how you subset by column. And for myself, I usually just work with variable names. And maybe that's why I don't know what went wrong there. All right, so that's subsetting by column. Let's subset by row. We're gonna do the same thing, Gapminder, and then filter where year, which is one of the variables. And I'm gonna use the double equal sign for equivalency, equals 1987. And because 1987 is a year, I don't have to do anything special. If it were character data, like let's say, well, I'll come back to that, 1987, 1980. Now, when I run that, when I execute that code chunk, then you can see I now have subset down just to 142 rows. And if I scroll through this, every single one of them has the year 1987. Now you can mix and match those things, in case you're wondering. I can put in another pipe and then, let's see, filter continent equals, and now continent is a text variable. It's actually a categorical variable, but it's text for sure. And so I'm going to put in Oceania. Wait a minute. I better not do that because one of the things you're noticing is, here we go. I always say I'm the world's worst speller. It's amazing I ever got a job in a library. There we go. So there's a combination of doing two filters at once, right? 1987 is one filter. Oceania, if I'm saying that right, is the second filter. And that works. So filter and select. Now I want to introduce to you how to sort, which is with the arrange function. So I'm going to sort by population. If I highlight Gapminder, the data frame, and hit Control Enter, I can execute just that one line. And that gives me a view of the data frame so that I can do what's being asked here, which is to sort by population. And I wanted to remind myself what the population variable name was. So Gapminder arrange pop. And if I do Control Enter, it's going to execute that whole expression from Gapminder to pop. And now what I've got is all of this data listed in ascending order by default, right? So if I go all the way to the end here, or to the end of the memory, it's a much larger number than what's in row 1. Sort continent in reverse alphabetical order. So I can sort not just numerically, but I can sort alphabetically. So arrange continent. And it said in reverse alphabetical order. This technique of reversing works both for numbers and for letters. I'm just going to embed an additional function inside of the arrange function. So I'm going to highlight my variable, this continent, and I'm going to press my shift key down and my open paren key. And that's going to wrap the whole thing in another set of parentheses so that I can add my other function embedded inside the first one. And I'm going to type in the function descend for descending. So that's reverse, right? Descending alphabetical order would be reverse alphabetical order. And if I run that, then you'll see that I have listed at the top all the Oceanias first. And if I scroll through them for quite a while, then I get Europe. And it just keeps on going. Eventually get to some other continent. But another thing to point out is I can subsort, right? So not just reverse alphabetical order by continent, but I can also reverse the alphabetical order by year. Let me go back up here to row 1. Actually may already be in that order. Let's see what happened. I think it's in ascending order, right? Oceania 1952 all the way up. So let's put year here and do the same thing, descending, and run that command. And now you see how I can subsort just by adding more commands. I think I've said this, but I feel a need to point this out right now, that these changes that I'm doing right now are only temporary. I'm not changing the original data set, right? So if I write Gapminder down here one more time, and I execute all 3 of these commands, I will get 3 data frames. The first one is arranged by population. The second one is descending order of continent, sub-arranged by year. And the third one is just the full data frame. If I wanted to fix this version of the data frame and deal with it later in just that sorted order, what I would do is I would use that assignment technique that you saw me do several times before. For example, when we opened up the session, I did this. John, and I forget all the other names. I put Layla, and Buki. All right. So I'm going to use that same technique, and I'm going to say, I'm just going to call it sorted Gapminder. and put in my assignment variable. I'm going to comment this out because I don't actually want that to run. Now I can do that, but again, I'm just going to reiterate. When I do that, I won't actually see 3 data frames because when you assign it, all you're doing is assigning it. It's not going to display by nature, right? Let's look at that. So now I have the 2 data frames. The first one is displayed, the third one is displayed, and the second one is kind of invisible. It's actually, I can, if I zoom back out here and look at my environment variable, it's right there. And notice, by the way, Gapminder is not in my environment variable because Gapminder is an onboard data set. It's a weird little funky thing. But if I want to see it, it's so simple. All I have to do is type it again, sorted Gapminder. And now when I run these 3, I'll have 3 data frames. This one, anytime I refer to sorted Gapminder, will always be the same, same particular view of Gapminder. So it might make actually more sense if I did something like this. Select country, year, and pop. All right, sort of making a compound sentence. And so the difference that you can see right here is that it's not immediately obvious. These 2 data frames are sorted, but they're the same size, whereas this data frame, only 3 rows, 1704 by 3 rather than 1704 by 6. Okay, so that's a good review of, I see that we're at 1 hour 40 minutes. Let me see what my time is, 3:30. We got a half an hour to go. Is that right? No, we're done. Oh my gosh, sorry. I was 20 minutes behind schedule. All right. I don't want to presume that you guys can hang with me all day long, but I'm sorry that I lost track of time. I will be happy to continue this so that there's only a couple more rows here. I'm not going to get to visualization, but I will invite you to sign up for my part 2, or you have access to all the videos, and you can always schedule me for a consultation. This aspect is super helpful because one of the things about visualization is you often need to get your data subsetted in just the right way, or subsetted or wrangled. And so dplyr is very helpful for that. So I'm going to keep on that track. Sorry I didn't get to everything. And I know some of you have to go. Okay, so mutate, super helpful because that's how you create new variables. So the goal here is to create a new variable called double life. You may have seen an example. We did an example of this kind of earlier. Mutate. And by the way, same goes for you, Drew. I understand if you can't hang around. I'll do my best to manage the chat. Mutate a new variable called double life. And double life, I'm going to use this assignment variable equals life expectancy times 2, right? Now, when I execute that, I now have 7 variables, which I can see right there. And there's double life, which is double this, right? Life expectancy times 2. Count can be really handy. Count how many observations exist for each country. So I could just do something like this, count country. And this will be a little underwhelming because it gives me the same answer for every country because this is a very clean data set, right? Every country is listed in there 12 times for the 12 different year timestamps for which they collected population data. But one of the things that you can do with that, like it's an easy way to figure out what countries are in the data, or in the, what are the variables that exist within the country column? What are the values that exist within the country column? So you could use count. There's another way to do that, however, which is this nice command called distinct country. So I can do distinct continent. I'll do continent this time. And it just gives me, like, that's a great way to go, well, which continents are represented without scrolling through the whole data set. Now I see my folks are dropping like flies, so I appreciate anybody who's still here. And of course, there will be the video. We're going to introduce the concept of sum, right? What if I wanted to sum all of the population column? Well, in order to do that, I kind of need to know two things. One is that there is a function called sum, right? So I could do this, sum 5, 7, 10. And if I run that, I get an answer, 22. But I want to sum the whole column for Gapminder. So let's say I want to sum all of population, which of course doesn't make any sense because I have lots of different years here, but it proves it shows you a good function. I can just type summarize, and I'll point out another thing. Tidyverse and R was super popular in New Zealand. In fact, kind of the rock star of the Tidyverse, a guy named Hadley Wickham, is from New Zealand. So they have both British and English spelling, and you can use either. So I tend to use the summarize with an S first because it's the first one and it's convenient. But if you wanted to spell it with a Z, that'd be fine. And then I type summarize pop, and you'll see what happens is, I'm sorry, I did that wrong. What I wanted to do is type total pop gets value from the function sum of pop. And then I get this really big number. Turns out to be like 50 billion, which is not a particularly useful thing to do right now because it's out of context of the data that I opened up, but you may have a different column where you do need to get a column total. Now, that's what summarize does, but usually we don't use summarize by itself. We usually use it with a function called group by. So I can do something more useful, like say, group by year. And if I just run this, it really won't look any different. I just get an extra message up here that says I've got 12 groups, one for each year, one for 1952, 57, 62, etc. But then if I combine that with summarize and do the same thing, total pop gets value from sum of pop. Now I have a data frame of population totals for each year across the whole world. And of course, I can see that going up. I'll also note, I know this is a really hard number to look at, but it's a numeric data type. And so the fact that it's hard for me to look at kind of means that it's easy for the machine to deal with. But if I needed it to be easier for me to look at, I could do something like this, where I add another function, scales, comma. So from the scales library, use the comma function. And when I run that, I now have for me, much easier number to read. The only downside to that is it changed my data type. So now it's considered a character. And it's considered a character because it has commas in it. And the downside to that is I can no longer do math on it, right? Because it's not numeric. So kind of have to be careful of those kinds of things. But it's worth knowing about. And I'm almost done. Just another thing to point out here, and I'm going to grab this code chunk, copy it into my buffer, and paste it right here, is that summarize can do more than one thing, right? So I can say mean pop gets value from, use the mean function and type pop. And now I have grouped by year, total population, and the mean population. And again, the difference in these two is that I force this one to display so it's easy for me to see. And this one is still a numeric double floating point variable that's easy to do math on. And I could easily visualize that And so I actually am going to just real quickly, it won't take me much longer, and then I promise I will stop. I could send this to the visualization package called Ggplot. And Ggplot wants as its first argument to be a data frame. But we did that up to here. We wrote a data frame. So then we're saying, and then go to Ggplot. And then another argument that I need is the aesthetics argument, where I identify the X and Y values of my whatever I'm trying to visualize. In this case, I'm going to try and visualize a scatter plot. So my X value could be year, and my Y value could be mean pop. And then I need one other thing, and this is where it gets weird, I'm sorry. I'm no longer going to use the conventional pipe because Ggplot is the first in the evolution of all the packages like Tidyverse, and it uses a different conjunction. It uses a plus sign. And I'm going to pipe that to a particular layer, visualization layer technique to make a scatter plot. There are tons of geom functions. If I just go here and hit tab, I can make an area plot, a bar plot, a box plot, list goes on. The geom point is the one I want. And if I run that, then I have this nice scatter plot. I could actually make it a line plot just by changing the geom function. And you can see that right now my scale is in scientific notation, which is also hard to read. So scale Y continuous labels equals scales, comma. See if I got that right. I did, yay. It's so kind of you guys to still be here with me. I'm sorry I went so long. I don't want to take up any more of your time. I will make the video available. And I encourage you, one of the ways I want to encourage you to use R is to take what you've learned here today. You always got to kind of start small. Find a project that you've already done. Like if you're an Excel user, don't make it a super elaborate project and just try and replicate what you can do in Excel in R. And what you'll find is that it'll force you to realize the stuff you don't know, and it'll force you to realize how to overcome those things. And as you're overcoming those things, you're learning new stuff. So it looks like my buddy Drew took off, and it looks like I have some chat. So I'm going to open up the chat and say, bid you goodbye. And if anybody wants to unmute and ask a further question, I got nowhere to be. Thanks so much. Good luck, and reach out to me if you have any questions.
Hey, John.
Hey.
If I could I circle back to just the differences between our script and our notebook and our project? I definitely understand the value of our markdown now because you went through that very well. But I just don't quite know what the difference between the other three are.
Okay, so our script and our project. And R script is a different way to do an R markdown document. And what I would say to you is, if you're new coming to R, I would say don't bother learning R script. It's like the old school way of doing it.
Yeah, that's how I initially learned.
Here's the caveats. Okay, well that's fine. And you can keep doing that. The difference is that in R script, you can't integrate the prose, right? So let's take something like this section right here. Now let's make that an, oops, I don't know that I meant to do that. I'm going to copy that and I'm going to make it an R script. File R script. And I'm going to paste it here, and I'm going to get rid of my well, I don't have to get rid of my prose, but my prose has to be a comment. So I can do something like this, library tidyverse. And then I don't need this. And I also need Gapminder. Library Gapminder. So I don't want to get too like weird or authoritarian about this. Like, this is fine. If this is what you like, don't change on my account. The problem that with this approach, from my point of view, is only that what we seem to know about coding is that when you have to write comments like this, it's so inconvenient that people tend to devote short shrift to their commenting. And so over time, what you get are code scripts that are kind of hard to read because they're sort of idiosyncratic to whatever you're doing, and nobody really goes back and comments it that much. It's not that you can't also write hard to read code in R Markdown. It's just that what R Markdown brings, and our notebook brings, is that ability to intersperse natural language with prose and then generate all kinds of derivative outputs, like a dashboard or a set of slides. Whereas in this case with R script, it's actually a fair bit of work to generate different kinds of outputs. If you don't ever want any other kind of outputs, all you want to do is save some pictures. I mean, really, this is fine. I think what I would suggest to you is I think that you will find if you start using R Markdown, the more you use it, the more you'll like it. It may feel foreign at first, but eventually it will feel very convenient. But again, don't change on my account. There's nothing wrong with .r. It's been around for ages. It will continue to be around for ages. Lots of people use it. But what you see here, this is an R script. So if I then save this, I'm generally going to save it as, I'm going to call it example 2 dot with a capital R, save. And let me zoom back out on my, so here's my R script with a .r. And with this .rmd, I can create all these kinds of report derivatives. But the executable stuff in a .rmd exists within a code chunk, whereas the executable stuff within a .r is just there. And then you have to kind of go out of your way to make your comments kind of protected from the execution. So that's the only difference. I hope that makes sense. The issue with projects kind of has more to do with reproducibility and setwd than it has to do with the scripts themselves, right? So one thing that you'll see is that a lot of people will do something like this at the top of their screen in an R script in particular. Like, so if I type this command, get wd, it gives me a response down here in my console of what the working directory of this project is. So if I want to use relative file paths, which is just one of the best practices for making reproducible code or reproducible projects, then I would, in this context, I would have to say set wd at the very top of my script, and I would have to set the working directory to an idiosyncratic location that is specific to my particular computer. And what that means is every time I run this, I can then do this, read, among other things, read CSV data. I'm going to call this my data 2. I can then do this. So everything here is now data is a subdirectory of this working directory. The problem is, and the reason to get out of that habit is that if I share my code base with anybody else, they have to go and find wherever the setwd command is. I mean, ideally it's up at line 2, but it might be at line 10 or it might be at line 15, and I might not even know it's there. And I'm always going to have to troubleshoot your code if you give me your code in that manner, and I'm going to have to make that change specific to my computer. Now that's, if you don't mind me saying, in my mind, that's sort of pernicious enough, or if it's not pernicious, it's a hassle, it's kind of a pain. But that's, well, so what? Like you might go, so what, John, I'm not going to share any code with you. Fair enough. But who you are going to share code with is yourself, right? And what I mean by that is you're going to replace your computer sometime. And if you've got all this code base from your last computer, unless you're very careful about moving all of your projects into the exact same file locations, then you're going to have to go back and not only rewrite setwd, but anything else where you're using explicit file paths to reference things like saving outputs and whatnot. So if you get in the habit of not using setwd, but instead using an R project, then what that means is by default, the R project is just going to bring this along no matter where it exists. So when I mentioned to you that on GitHub, you could grab this repository, you can click the download zip, you can expand that. And when you expand it, let me go back to the, I expanded it from onto my desktop. And now if I run that, what I'm going to do is I'm going to shut this down. I don't know that I want to save those things, so I'm going to say don't save. And I open the project this way, right? I haven't, I'm actually working, although it's probably not obvious, I'm actually working on 2 different computers during this session. One is my home, it's actually my work laptop, and another is a virtual Windows machine. So they don't have the same file structure. And now that I've used this as an R project, if I just type getwd right here and run that command, that's telling me that this project exists on my desktop. But if I go back to I'm going to switch here to my, on my home computer, and I run this project and I type getwd. I don't know why I have my caps lock on. You can see that this project actually exists in an entirely different place, the documents folder versus the desktop folder. So even though they're in different places, it's all going to run because I've been using relative paths. So I hope that begins to explain why you want to use a project. Another reason why is because I can have multiple projects open at one time. So I can go through my short list of recently opened projects. I can go down here and I can open up this attendance sheet workflow. If I click here, it's going to replace the one I have. If I click here, it's going to open it up. And now I have 2 projects. And they're actually going to share different environments. So I have no concern of running the risk of what if I use the same variable name in both of those projects? Do I need to be careful about what order I run scripts because I might have accidentally overwritten a variable name? It doesn't matter because they're in 2 different projects, there are 2 different distinct sort of RAM spaces, if you will, and they're not going to bleed into each other. I think that's the sort of the short of it. I don't know if I'm making the case compelling, but I hope that I'm explaining why you would do it. And if you have follow-up questions or if I still haven't gotten to the nub of it, let me know and I'll be happy to give it another go.
That's very clear. Thanks so much.
Yeah, thank you, John. That makes a lot of sense. I guess I saw it in the beginning of your first video, you made a new folder first, and then you made that new R project. So you need to do that step in order to have this 2 different R project spaces you can be running at the same time and all of that.
So not really. That's one way to do it. And I realize that I'm probably throwing there's you can do it this way or this way or this way or this way, and that can be kind of I don't get it. Which one am I supposed to do, right? But the easiest way to start a new project is to go up here in the upper right-hand corner and choose New Project. I'm actually going to do this on the virtual computer because, oh, I forgot. I don't know if you guys saw everything I was doing. Do you see a blue screen right now or a white screen?
We have a white screen right now.
Ah, okay, well, sorry. Let me go back to my white screen. I just showed a whole bunch of stuff that probably didn't get translated. But, all right, so up in the upper right-hand corner, you see Intro to R Exercises -master. And if I click on that, this is what I would normally do, is I would normally actually click New Project right here. and then a wizard will come up. You'll saw that there was a little delay. And the way I showed you in the video was applying the project status to an existing folder where I had already moved stuff into it. But for me, it's actually easier because I'm always in R to just start a project by clicking new directory. So I can start that here. Go ahead, sorry.
Does it make a new folder?
Yeah, yeah. So when I click on new project, I can now call this, if you'll forgive me, I always call things that I know I want to delete. I always start off by calling them delme. That way I know when I run across it that I did this for some workshop and it's probably no longer relevant. But I'm going to call it delme Anna, and John analysis. Now, by default, it's putting it in wherever RStudio wants to stick all of my projects. And that's what that tilde means. That tilde means wherever you're sticking all your projects. But I could literally put it anywhere, right? So I'm going to put it on my desktop again, like I did before. And that's going to change this, but that's just whatever, however you want to navigate your file system. And then when I click create project, it's going to close that project that I had open, unless I had checked a different checkbox. And now I have a new project. So now when I minimize everything, here's the project I was working on earlier today, and here's the project that I just created. And it doesn't have anything in it except this one file. So you can do it that way. I find it more convenient to start the new project from within RStudio, but that's because I'm always in RStudio. And I don't really have a preference. Like the other thing that's probably worth noting, I didn't show this, but let's see, where's my web browser? Hopefully, you did just see my desktop, right? A second ago? Okay, good. I'm never sure what I'm doing on Zoom. To be it's such a weird environment. So if I go back here to GitHub, I didn't show this before, but what I showed is the always works method where you download the zip file. But if I grab this thing right here by clicking on this clipboard, which gets this code, I can then create a project in RStudio with just that. So I'm going to go back here. Now I'm in RStudio. Now I'm clicking our new projects. It wants to save some stuff. I'm going to say don't save. And then I'm going to go down here to version control and choose Git and paste that thing in that I just put in my buffer. And now, and at this time, I'm going to click open in a new session so that I can keep them both open, and click create project. And now what it's going to do is create a local project from a GitHub project. So I realize that this can be kind of weird, but you can think of, I mean, to me, I guess the analog is when I used to use Microsoft Office all the time, I was writing reports for different discrete things. Let's say classes. I have a sociology class and a math class. So in my documents folder on my directory, I would have, well, I'm not going to say math class because I wouldn't have written a report for a math class. So it's a history class. In my documents folder, I'm going to have one folder called Sociology 101 and a different folder called, History of the Spice Road, right? And I'm not going to bleed different parts of my report into those two folders. Those two folders are discrete. And that's all an RStudio project really does, is it allows you to keep discrete things on your file system and then leverage stuff like the relative file paths and stuff like that. So you can put them anywhere you want, but in practice, I have like a godzillion number of, probably won't see it on this computer because this is a virtual computer, but if I open up the file manager, yet another view of the file manager, I have a ton of projects in my documents folder, and they're all RStudio projects. I mean, they're actually different. There's some Zoom projects and some Panopto projects and stuff like that, but most of them are, in my case these days, just RStudio projects.
That's really helpful. Just the whole setup. That was, I mean, I rewound the first part of your video because we do a lot of data manipulation in order to start our analysis and do our analysis. So we're running similar code, over and over again, and it's just the organization of this is really helpful, to have it all in that one project, and then you're getting to see them pop up. Like that's great. Definitely going to steal it.
Good. I'm glad. That's exactly the use case. Like it really is all about organization. It's about, getting the same results with all of your collaborators.
Mm-hmm.
Right.
Yeah. Thank you.
Sure thing.
Hi, John, it's Dawn here.
Hi, Dawn.
Hi, I just had a real quick question. I wrote a question in the chat, so I'll just say it. But I work with the microbiome data, and it's compositional. So at some point in time, do I need to change my feature table or biome file or metadata files into a matrix?
I don't think I can answer this question.
Okay.
Well, I don't want to say definitively that I can't answer the question. I don't think I can answer that question right now without kind of seeing what you're doing and understanding, because your area of expertise is not mine. Like I'm much more involved in social science, and I don't really totally get what you're talking about. But I would be happy to have a consult with you, have you show me what you're doing. We could share screens on Zoom, and I could try, and I will certainly give you my first impression. My off-the-cuff answer is, for myself, I tend to never use matrices. I like the convenience and the simplicity and the sort of metaphorical simplicity of a data frame. But sometimes you have to do matrix algebra, and you have to use a matrix.
Right.
And so kind of depends on your context. Data frames, which in a tidyverse context can also be called tibbles, they're really super convenient, but the people who develop them are the first people to say a data frame is not the right format for everything, right? It is a great way to organize a lot of things. And what makes matters even kind of more complicated is in R, you can have data frames, or you can have vectors, or you can have lists, and the lists kind of always sort of manage to boggle my mind. No matter how many times I look at them, I go, I don't know what this thing is. And the reality is, what's really crazy about it is that actually everything, just about everything in R is actually a list. So a data frame is technically a specialized R list. So for ease of my mental model of thinking about the data, I like to put it into a grid, rectangular grid, as a data frame as often as possible. But I would never say like you must use a data frame, because it really depends on context. And you may be running across packages that you're using where that's a requirement to have it as a matrix. And there are some convenience factors, right? You can use commands like as tibble or as data frame and as matrix and shift them back and forth, usually non-destructively. So you might want to shift it into a data frame to look at it, but into a matrix to process it.
Right.
Anyway, long story short, feel free to set me up with a consultation and we'll take a closer look.
Okay, thank you.
Yeah. All right, folks. I probably should turn the meeting off, but if anybody has one last question, let's go ahead and answer that. And if not, I couldn't thank you enough for your time and attention today. All right, take care.